Okay, so now we're going to take a look at the second part of the review that I would like you to know, and this will deal a little bit more with radicals and simplifying and conjugates. Okay, so the first thing I would like to do is to simplify the square root of negative 72. Now, notice for number one that it is a negative under the square root. If you recall, I can rewrite that as the square root of negative 1 times the square root of 72. Now, you should know that the square root of negative 1 is equal to I. So you know this is going to have an imaginary unit at the end of the problem. The other part is, though, is to be able to pull out the perfect roots of 72. Now, if you know your perfect squares, that's great. You can avoid a lot of what I'm going to be doing right now. If you don't, I'm going to create a factor tree for this and simplify. Okay, so factors of 72. Well, there is going to be 8 and 9. Okay. I know 9 breaks down as 3 times 3. That part is done. Okay. Now, for 8, I know this is going to be, I'm going to rewrite this over here as 4 times 2. 2 is prime. And 4 breaks down as 2 times 2. Right? So the square root of 72 is equal to 2 times 2 times 2 times 3 times 3. Now remember, because the index is 2, I need 2 of the same factors to get 1. Notice I can circle 2 2's and 2 3's. That's the same thing as 2 times 3 times the square root of 2. Well, 2 times 3 is 6 times the square root of 2. Now, don't forget, we had an I also. So the square root of negative 72 is equal to 6 times the square root of 2 and I. Now, you can also rewrite that as 6I times the square root of 2. But notice the I is not inside the radical. Okay, let's take a look at number 5 then. This is an example of what is called rationalizing the denominator. Now, all that means is we want to get rid of all the radicals in the denominator. So, what can I do here? We know the square root of 3 times the square root of 3 is the square root of 9, which is 3. So with a square root, I can multiply the radical by itself. Now keep in mind, I need to multiply the top and the bottom by the square root of 3 because you're multiplying by 1. And when you multiply by 1, nothing changes. So on the top, I have 5 times the square root of 3. Don't combine them. One's number is inside the radical, the other one's not. So don't combine them to make it the square root of 15 or 15. The square root of 3 times the square root of 3 again is the square root of 9, but more importantly, that is 3. Okay? That is rationalizing the denominator. Okay? All right, now let's go down a little farther on the page and talk about writing the conjugate of negative 3 plus 2i. The conjugate means that the sign in between the terms is going to change. So for example, I'm not going to change the negative 3 to a positive 3. But what I would do is I would take the positive that's in front of the 2i and make it a negative. So the conjugate for negative 3 plus 2i is negative 3 minus 2i. The nice part with the conjugate is if you multiply these together, you will have no terms of I. Okay, the last thing I would like to do on this review is to simplify 27 taken to the 2/3 power. Now, I will show 2 different ways to do this. Option 1. I can rewrite 27 as an exponent. Well, 27 as an exponent is 3 cubed. 3 times 3 is 9. And 9 times 3 is 27. Now, what do? When I take an exponent power to another power, I multiply. So it's 3 over 1 times 2/3. Notice the 3's divide out, that's 2. So that's the same thing as 3 squared, which is 9. So 27 to the 2/3 power is 9. Okay. Option 2. I can rewrite 27 to the 2/3 as, well, 27 to the 1/3 squared. Now remember, When you take an exponent power to another power, you multiply. 1/3 times 2 over 1, I'll write it so you can see it, is 2/3. Now, why did I put 1/3 on the inside? If you recall from a previous math course, that is the same thing as taking the cube root. So 27 to the 1/3 power is exactly the same thing as a cube root of 27. Well, what's cube root of 27? That's 3. And when I take 3 and square it, I get 9, which is exactly the same answer we got from option 1. Okay? So any of these problems from this video or the previous video, okay, you should be doing similar exercises from your book if you are having difficulties with this. Okay? See you soon with the next lesson.